Hello, my name is Aselisewine, and I'm currently working on a decision tree-based Curate model. Now, the Curate model is widely used to analyze a lifetime data that contains a Q fraction. When a lifetime data contains a Q fraction, it means that your population of interest is being divided into two, the Q part and the unQ part. When this is the case, we have a Kaplan-Meier curve that levels up at a non-zero survival probabilities. So this Curate model takes care of these two fractions of population. The model is defined in equation 1, and it consists of two parts. The latency part, which models the survival probabilities of the uncured, and then the incident part, which models the probability of an observation being cured or uncured. The incident part is usually modeled using the standard logistic regression. But the problem with the standard logistic regression is that when covariate has nonlinear pattern, the standard logistic regression doesn't provide a good fit. So in this study, I'm proposing to use a new model called decision-based Curate model, which will model the incident part using the decision-based classifier, and then it will model the latency part using the Cox-PH model. The Cox-PH model is maintained at the latency part because of its explanatory ability. We are using decision trees classifier to model the incident part because decision trees are very flexible and they can predict both linear and nonlinear complex patterns. To evaluate the performance of our model, we develop an efficient estimation algorithm called the expectation maximization algorithm, which enables us to estimate the parameters of our model and compare the performance of our model with the logistic model and then the spline model. We obtain data from two scenarios. The first scenario is complex data generated using two variables, and the second scenario is a more complicated data generated using 10 covariate. This data set was generated using 3 sample sizes. The data was divided into the training set, which was used to train our model, and the testing set, which we used to evaluate the performance of our models. The results obtained in Table 1 measures the mean square error obtained by each model. And as seen, decision tree has consistently produced lower mean square errors as compared to the other computing models. Using the test data to evaluate the performance of our model, we obtain higher accuracy for decision trees as compared to the other computing models. We illustrated this using a real data to validate our model. This real data are obtained from the leukemia study of 137 patients. We fitted a model that consists of 2 covariate, patient age and donor age. We obtained the estimate for each parameter and the standard errors. The results obtained shows that decision trees has lower standard errors as compared to the other computing models. And the predictive accuracy results obtained also suggest that our proposed models perform better than the logistic regression and the spline model. So in conclusion, we propose a decision tree-based Curate models which can capture both linear and nonlinear complex patterns to model a lifetime data that has Q fraction. Thank you very much.